A bicycle tire pump can become quite hot as it is used to pump air into a tire. Does this happen because of friction? It would make sense, right? I mean, if you've ever tried this out, like tried pumping with a bicycle tire pump and then at some point touch the cylinder, it will feel quite hot. And most of us will say, well, of course, I've been moving this piston back and forth, and so there's friction there, so naturally it gets hot. But maybe something else is actually more of a cause for that. I mean, I'm sure there's some friction there, but is that really it alone? Maybe another way of putting it is if I did this in a vacuum, so that as I moved, or moved the handle of the bicycle tire pump, if there's no air being pushed, would it still become just as hot because of friction alone? My answer is no, I don't think it would. We just looked at the first law of thermodynamics in relation to mechanical energy conservation. And on the way, we discovered what could be looked at as another way of stating the first law of thermodynamics, which was this one, that the heat added to a system plus the work done. And I'll once again bring in this too here, because the traditional form of the first law of thermodynamics, usually the work is considered to be the work done by the system or the capacity for the system to do work, is language you sometimes see as well. But this point of view really looked at it as like, well, these are the two possible ways of transferring energy into a system. And for the bicycle pump, clearly we're doing work to it. And if the cylinder itself is relatively isolated, which one could argue that maybe it would be, because it's surrounded by air, and it turns out air is a really good insulator. So I'm going to argue that at least to some degree of approximation, maybe the heat, maybe negative heating really, in the form of cooling is not really happening. I'm not holding the bicycle pump over like a Bunsen burner or something like that, or any other kind of torch or flame or whatever. So I'm going to argue based on that really I'm not doing anything to add or remove heat from that system. So if I do work to it, that should manifest somehow as increased energy in that system. And one of the possibilities is that goes into thermal energy. And of course, friction will do that, but it turns out compressing air will also do that. So we're going to study this in some more detail as a process later on. It's going to be modeled pretty well as an adiabatic process, it turns out. But definitely we can equate the amount of work done to the amount of thermal energy increase. And then if you know the specific heat of the air and the amount of it inside the pump, you could theoretically calculate what temperature increase that would correspond to, and discover that actually to a large extent predicts the heat, you could say, that you feel when you touch the bicycle pump. Let's check out what the slide says here. It says, not so much. The work done to pump the air also compresses it, and it manifests as an increase in thermal energy as the first law of thermodynamics predicts. And that last part is kind of what I've been talking about in relation to this formula.